This is tier 3, and then this is lesson 1a, quadratic graph. So now we're going to graph the function and find characteristics of the graph. So we have standard form, and we could find the vertex using that negative b over 2a we've been talking about. So let's do that first. So we have negative b, well b is already negative, so negative b, 12, over 2 times a, which is 2. So 12 over 4, 3. So our x value is 3, and we'll plug that in to find our y value. So y equals 2 times 3 squared minus 12 times 3 plus 16. 3 squared is 9, so 2 times 9 is 18, minus 36 plus 16. 18 minus 36 is negative 18, plus 16 equals negative 2. So our vertex is 3, negative 2. 3, negative 2. So 3, negative 2 is here. Typically we go over 1 up 1, but we're multiplying it by 2 because our a value is 2. So I'm going to go over 1 up 2, over 1 up 2, and then instead of going over 2 up 4, we're going to go up 8 because remember we're doubling from our a. So over 2 up, and the symmetry on the other side. So there's a rough sketch. Now there is no maximum because it goes up forever, so I'm going to say none. The minimum value is negative 2, and it occurs at 3. I'm going to label this point 3, negative 2. The x-intercepts occur at 2, 0, and 4, 0. And the y-intercepts are going to be even higher. I'm not exactly sure because of my graph that's off there. It's going to be 16. If I plug in 0 for x, well, 2 times 0 squared is 0, minus 12 times 0, and there's all of 16 left over. My domain is all possible x values. Well, you can see that it goes up forever and to the left forever. So every single x value is going to be hit because of that left. So from negative infinity, and then we're going to go forever and ever and ever up and to the right. So we know that every x value is going to be hit until infinity. So from negative infinity to positive infinity is our x values. My range is all possible y values. You remember that my minimum y value is negative 2, and then it goes up forever and ever and ever. So my range is from negative 2 to positive infinity. It never goes any lower. It only goes up. Increasing is where it's going up. So it starts increasing here at 3, and then it's increasing forever to the right. So from 3 to infinity. Then it's decreasing from negative infinity until 3. It's decreasing forever and ever and ever until this point. So from negative infinity till 3. It's positive. You can see there's two pieces of positive above this axis from negative infinity till 2. Remember, we use that union symbol for or because it's also positive from 4 for the rest of the function. So from 4 to infinity. Remember, on the x-axis, and it's negative in between there from negative 2 to 4, this little piece. So it's negative from 2 till 4. And then finally our end behavior, as x approaches positive infinity, so as the x gets bigger and bigger and bigger, the y's also get bigger and bigger and bigger. So y approaches positive infinity, it's going up. As x approaches negative infinity, x gets smaller and smaller and smaller, our y's are still getting bigger, it's going up. So y approaches positive infinity. Okay, notice how these match. If it was a negative a value, it'd be pointing down and they would still match, but they would both be negative.